beneath the frigid skies of the Arctic, where the sun barely rises in winter and never sets in summer, stands a feat of modern engineering, a bridge that defies nature itself. This is the Hålogaland Bridge, Norway's longest suspension bridge above the Arctic Circle. But what did it take to build this marvel? How did engineers overcome extreme weather, dangerous conditions, and the challenge of constructing in one of the most remote locations on Earth? And why is it so crucial to the people of northern Norway? Buckle up as we take a deep dive into the incredible story behind the Hålogaland Suspension Bridge. For decades, traveling between the northern city of Narvik and surrounding areas was no easy task. Harsh winters and long detours plagued drivers, forcing them to rely on slow ferries that could be unpredictable, especially in stormy weather. The steep, narrow roads added another layer of danger, increasing the risk of accidents. Emergency services were frequently delayed, businesses suffered logistical headaches, and residents endured grueling commutes. The need for a more efficient, safe, and reliable route was clear. But constructing a bridge across the vast Rombaken fjord posed enormous challenges. Engineers and designers had to contend with icy waters that could freeze over in winter, Arctic winds that could reach speeds of over 100 kilometers per hour, and unstable geological conditions beneath the seabed. Yet, despite these obstacles, they set out to build the impossible. Building a bridge in one of the harshest environments on Earth is no simple task. Engineers had to design a structure capable of withstanding Arctic storms, freezing temperatures that could cause steel to contract, and the constant movement of the Earth beneath the fjord. The result? A stunning suspension bridge stretching 1,533 meters, 5,030 feet, with a main span of 1,145 meters, 3,757 feet, making it the second longest suspension bridge in Norway and the longest ever built north of the Arctic Circle. To handle the extreme climate, the bridge was built using high-strength steel capable of withstanding temperatures as low as -40 degrees Celsius. The deck was designed with aerodynamics in mind, reducing wind resistance while maintaining structural integrity. Special high-strength cables, each composed of thousands of steel wires, were used to ensure the bridge could bear the weight of heavy traffic, even under the harshest conditions. Wind tunnel tests simulated hurricane-force winds, ensuring that the bridge could remain stable even during the most extreme storms. The engineers also had to account for seismic activity, as even the Arctic is not completely free from geological movement. The construction of the Hålogaland Bridge was an epic undertaking. Work began in 2013, with engineers and construction workers facing some of the toughest conditions imaginable. Transporting massive materials to the remote site was a logistical nightmare, requiring coordination between land, sea, and air routes. Each of the bridge's two main pylons had to be carefully positioned and anchored deep into the fjord's rocky base, an operation that required precision drilling and careful placement to avoid destabilizing the structure. The steel cables, imported from China, were carefully strung across the fjord, a process that took months to complete. These cables, the backbone of the suspension system, had to be installed with absolute precision, as even a minor misalignment could compromise the bridge's stability. Workers battled freezing winds and icy conditions while suspending themselves hundreds of meters above the fjord, ensuring every component was perfectly in place. Despite these challenges, the construction stayed remarkably on schedule. The final phase involved paving the bridge deck and installing advanced monitoring systems to track stress, temperature changes, and potential structural weaknesses over time. After 5 years of relentless work, the Hålogaland Bridge officially opened in December 2018, marking a new era for northern Norway. The impact? Travel time between Narvik and surrounding areas was cut by 15 minutes, an absolute game changer for commuters, businesses, and emergency services. The economic benefits were immediate, with businesses reporting faster supply chains, reduce transportation costs, and increase tourism due to easier access to the region. But beyond saving time, the bridge represents something greater. It symbolizes connectivity for isolated communities, economic growth through improved transport routes, and a leap forward in infrastructure development in one of the most remote regions of Europe. Tourists now flock to see the bridge's elegant design, while businesses benefit from faster supply chain operations. It's more than just steel and concrete, it's a lifeline. Today, the Hålogaland Bridge stands tall as one of the Arctic's greatest engineering achievements. It connects communities, drives economic growth, and showcases Norway's world-class infrastructure expertise. But as climate change accelerates, bringing unpredictable weather patterns and rising sea levels, will this masterpiece stand the test of time? Engineers are already looking into future-proofing strategies, including advanced monitoring systems that can detect early signs of stress or wear in the bridge's structure. If needed, reinforcements could be added in the coming decades to ensure its longevity. Only time will tell how this incredible feat of engineering will adapt to the changing world. What do you think of this incredible Arctic bridge? Have you ever crossed it, or do you want to see it in person one day? Let us know in the comments. And if you love stories of remarkable engineering feats, be sure to like, subscribe, and hit that notification bell for more amazing content. Until next time, keep exploring and keep questioning the world around you.